Om Shri Sai Ram. Welcome to the third session of this chapter, Force and Laws of Motion. So, having studied that about basics of the force, how many types of forces are there, we have already studied balanced force and unbalanced force, and after that we have also studied the law of inertia, which is Newton's first law of motion, right? So, in this chapter, in this session, we will be discussing about an interesting topic which we call as the heart of this topic, heart of this chapter, called as Newton's second law of motion. Alright. So, before diving into this topic, let us answer some home assignment problems which I have given in the last class. So, what is the first question? Which of the following has more inertia, a rubber ball or a stone of the same size, and a bicycle or a train? So, we have already know that inertia is nothing but a resistance or tendency to resist the change in motion, change in the state of motion. Alright. So it depends, it basically depends on mass. So, a rubber ball or a stone which is having more mass, and they are also given it is of the same size. So, obviously we already know stone has the greater mass, hence it possesses more inertia. The mass of the rubber ball is much less than that of a stone of the same size. A body of greater mass, has more inertia. Hence a stone has more inertia, right? Now the second one, a bicycle or a train, which possesses more inertia? Yes, it's of course a train, because a train will have more mass. Obviously you can easily lift a bicycle but not a train, right? Real train, not a toy train. So a train will have more mass than a bicycle. Since more mass means more inertia, the inertia of the train will be more than that of a bicycle. Alright. So let us go to the second question. Explain why some of the leaves may get detached from a tree if we vigorously shake its branch. In rainy season, many of your friends will do this, right? So make your friend go under a tree and you go there and shake the tree. So what happens if if the tree is filled with rain droplets, it suddenly falls. In the same manner, what happens? What is asked here? Why the leaves get detached if you vigorously shake its branch? So the same thing. So what's happening here? The answer of this cause lies behind the Newton's first law of motion. What happens there? Let us see. Initially, the leaves and the tree both are at rest. Nobody is moving them, nobody is shaking them. Both are at rest. Tree is at rest, and the leaves which are attached to the tree are also at rest. But when the tree is shaken vigorously, before what happened? Tree and leaves are at rest. But when the tree is shaken vigorously, tree comes in motion because of your external force. What happens? It comes in motion. When the tree comes in motion, what is attached to the tree? Leaves are attached to the tree. Now, leaves will oppose this change in motion, right? See, why the leaves have the tendency to be in rest? They want to be at rest, but we are shaking the tree and the leaves are attached to the tree. Okay, thus, because of remaining in the position of rest, some of the leaves may get detached from the tree if you vigorously shake it. So, because they don't want to change its state of rest, that is the reason if you shake the tree vigorously, what happens? The leaves get detached. This is as simple as that. Alright, this is the answer for your second question. Now third question. A moving body can continue moving on a frictionless surface only when a force is acting on it. Whether it is true or false. If you answered it, you need to also justify your answer. Alright. So let us see, a moving body. A body is already moving. Continue moving on a frictionless surface. It is a frictionless surface. That means there is no opposing force to stop it. Okay? Only when a force is acting on it. Okay? A body can continue. So we are claiming that a body only can continue when a force is acting on it, and it is also moving on a frictionless surface. Should I need any external force if the body is already moving on a frictionless surface? What your first law says? Your first law says that a body changes its state of motion when an external force is applied on it. A body is already moving, and our aim is to make it continue moving. Then is there an external force required? No, it is not required, because there is no opposing force. It is a frictionless surface, right? That's what your answer is. False. So there is no need of external push for the body which is moving in a frictionless surface. All right. So your justification is, according to the Newton's second law, according to the Newton's first law, a body can continue to be in the state of motion until and unless an external force is acted on it. Right? This is your first law. In our case, the body is already in the motion on a frictionless surface. Hence, there is no further need of an external force to make the body move. I hope this is clear. Now let's go to the last question. Inertia is only valid for the objects at rest. Is it true or false? If you write the answer, you need to also justify the answer. In our first question itself, we have seen that inertia is depending on the mass, right? Yes or no? Inertia is nothing but the tendency to resistance, right? So whether it is moving or whether it is at rest, it does not want to change its state of motion. So it does not only valid for the objects at rest, it is valid for the objects in motion or at rest. The only the body need to have is, it need to have some resistance which comes under mass. If it has mass, it can show some resistance. So it is false. So inertia is valid for all the objects having mass, whether the object is in rest or in motion. So this is what your home assignment is. I hope all have answered it before I even answer it. So let us come to today's session. What is today's session? We have already discussed, this is Newton's second law of motion. Before going to Newton's second law of motion, we need to know what are the physical quantities that define the motion. Okay, what are the physical quantities that define the motion? Let us see. So the motion of a body is represented by two physical quantities. Two physical quantities in dynamics. Dynamics means which is not static, which is moving. All right. So this is the part of dynamics. So we represent the motion of a body by two physical quantities. What are those? They are, one is momentum. One is momentum. Second one is kinetic energy. In this session, we will be deeply discussing about the momentum. This kinetic energy we will be studying in the chapter called work power energy. So you need to understand, when a body is motion, the physical quantities that define the motion of the body are, one is momentum, one is kinetic energy. So what is momentum? Okay, let us see. Let us have a question for you. When two stones of different masses dropped from the same height on a vehicle, which will cause the greater damage? So for example, take an example of, you have two stones of different masses. Okay, this is a smaller stone. Okay, for example, this is a bigger stone. This smaller stone, this is M1, this is M2. So they have been dropped from the same height on a vehicle. So let us suppose they have dropped from the same height. This is the same height. This height is h. Now this is a smooth floor. So what happens? It falls down. It creates a dent here because it's a smooth floor. When it falls, it also creates a dent. Now, which will cause the greater damage? Okay, what will cause it a greater damage on the ground, or which will cause itself a greater damage if this is fragile and the ground is rigid? So what do you think? Yes, your common intuition says that this mass, the mass of greater body, the body which is possessing more mass, what happens? It will create a greater damage on the ground, or it will cause a greater damage to itself if it is more fragile. So what our conclusion is, obviously the larger stone causes the greater damage. And why is that? Because since the larger stone with the greater mass, applies greater force even though both stones have same velocity when they touch the ground. So you already know, you will be knowing in the kinematics, you have already studied the motion, right? The equations of motion. This is m1, this is m2. When they reach here, what will be the final velocity? This is v1, this is v2. Final velocity will be what? v1 is equal to, if this is height from which both the objects are being thrown down. So what happens here? v1 is equal to square root of 2gh. Same, v2 is also equal to square root of 2gh. So both the velocities when they are touching the ground are equal. Still the object having more mass is creating more damage. So what does that mean? What does this mean? So here a quantity which here the motion of the body is depending on the mass, right? Here a physical quantity which we are going to define, that physical quantity is depending on the mass, right? This is your deduction. So now let me ask one more question. If two stones of same mass, that time it was different, now two stones of same mass from different heights dropped on a vehicle, which one causes greater damage? So now two stones of same mass, m1, this is also some m1, this is the ground, okay, this is the height h1, it is falling down, this is also falling down, and this is the height h2, and you already know that from the figure h2 is greater than h1. So when it falls down, which body will cause more damage? If you have a car here, okay, you drop two cricket balls, this from 10 meters and one from 20 meters, I mean less height and more height. Which impact will cause more dent on the car? The impact from the m1 or impact from this position, A position, or impact from this position? Obviously impact from this position. Why? Why? Because when it is reaching down, what is its velocity? V is equal to square root of 2g h1. This is v1. Here let us suppose v2. When it is reaching here, it is v2. So v2 is equal to square root of 2g h2. right? So it is having more velocity because h2 is greater than h1. So this ball is traveling with more velocity. So it will have more impact, right? So the physical quantity which we are trying to, or the physical quantity which you are trying to define is also depending on the velocity. It was depending on the mass, and now in this case it is also depending on the velocity, right? Now let us explain qualitatively. So the stone falling from the greater height produces the greater damage, right? Why is that? We have just proved it. Why is that? Because the stone falling from a greater height will have larger velocity, right? It is square root of 2gh, where the height is more, the velocity will be more, and it applies the greater force. That's why the damage will be more. In your daily life examples, you can also see that when you catch a cricket ball, if it is of the certain height, certain less height, if it is coming flat, it is very easy to catch with less force. If the same ball, if it is coming, if the batsman hit in the air for a very long height, what happens? Your hand hurts when you catch the ball, because when the ball is coming down, it is coming down with the greater velocity. So you need to apply more force to counter it. All right. So this is what about the physical quantity which we are going to define. Obviously, what is that physical quantity? That physical quantity we were talking about is nothing but what? Momentum. So now one more scenario we are having. If two stones of different masses are dropped from a different heights on a vehicle, which cause more damage? Now you have a car, two different masses, different heights. Okay, so which object will cause more damage on the vehicle? So you just think of the last two scenarios where we have talked about the physical quantity was depending on the mass, and the motion also depending on the what? Velocity, right? So our intuition says that the stone of larger mass dropped from a greater height causes greater damage since its product of mass and velocity is larger, right? When the body is hanged, when the body is left from the greater height with more mass, it will create more damage, right? So this is all about the physical quantity which we are going to define. So the physical quantity, as I have already said you, this is nothing but we call as the momentum. Then what is momentum? Momentum of a body is defined as a quantity of motion contained in it, and it is measured as, we already know it is depending on the mass and velocity. So both combine the product of mass and velocity. Momentum is nothing but the quantity of motion contained in it. How fast it is moving? If you have to define a motion, you need to know how fast it is moving and how much stuff is there in that object which is moving. If a fly is coming at you, if I just say a fly is coming at you with, if I just say something is coming at you 30 kilometers per hour, should you be bothered? Just I said that something is coming at you 30 kilometers per hour. It is incomplete information, because a fly may also come, a lorry may also come. Which will have more momentum? Of course, lorry will have more momentum, right? So it is the quantity, of motion that is contained in the object, that is called momentum. Now, it is denoted by the letter P. Why not M? Because mass has already taken the letter M. So the momentum is defined by letter P. All right. If the mass of the body is m and the velocity of the body is v and it is moving with the velocity v. If the mass of the body is m and it is moving with the velocity v, then the momentum is given by P is equal to m into v. It is a product of mass and velocity, which is called as momentum. I hope everything is clear up to now. What is momentum? On what factors that momentum is depend on. Alright. So now let us see the units of momentum. So what is momentum? Momentum is product of mass times velocity. Right. Now remember this. So what should be the units? What should be the units? In CGS system, it should be gram centimeter per second, right? In CGS system, mass can be grams. Mass is what measured in grams, and velocity is measured in centimeter per second. So that is what it is given. In SI system, it is kg. So this grams becomes kg and centimeters becomes meters. So that is what SI system of the SI units of the momentum. Okay. Now you need to also note that what are these arrows here? P equal to mv is okay. What is that arrow? That says that momentum is a vector quantity. It is a vector quantity whose direction is in the direction of velocity. So right, momentum direction is in the direction of velocity. Understood? This is a constant, mass is a constant, momentum will be always in the direction of the velocity. Okay. I hope everything is clear up to now. We have defined a motion, that is a physical quantity which defines the motion, right? Okay. So according to the first law of motion, if no external force acts on a moving body, then it moves with a uniform velocity, right? That is what we have, that is a law of inertia. So if there is no external force, that means what? There is no change in velocity, that means the velocity is constant, the velocity is uniform, the velocity is constant, it is moving with the uniform velocity if there is no external force. That means if no external force act on a body, its momentum, why I am writing now as momentum? Because the velocity is constant. If you multiply its mass to the velocity, and mass is also constant, right, then the momentum also remains constant as there is no change in velocity. If there is no change in velocity, I can say that if there is no force, the momentum also does not change. To change the momentum, what you should do now? You know, velocity is not changing, the state should not change when there is no external force. That means momentum is not changing when there is no external force. But hence, when the momentum of a body changes, if you want to change the momentum of a body, then the body must be under the action of a net external force. Have you understood now? See how we are linking, how we are deducing. No external force, the body is moving with uniform velocity, right? No external force, the momentum of a body is constant. In order to get the change in momentum, what you need to do? You need to add external force. This is the informal definition of the Newton's second law. Alright. Now let us go to the formal definition. Newton's second law of motion. The rate of change of momentum of a body is directly proportional to the net applied force and takes place in the direction of force. Understood? Once again, the rate of change of momentum, see, the rate at which the momentum is changing is directly proportional to the net force applied. To the net force applied and takes place in the direction of force. Right? Let's go qualitatively define what is Newton's second law, what it says. Okay. First thing, acceleration is produced when a force acts on a mass. The greater the mass of an object is, the greater the amount of force required to accelerate the object. What does it say? See, acceleration is produced when a force acts on a mass. When you change the velocity, what do you expect? Acceleration is produced, right? Rate of change of velocity is nothing but what? Acceleration. So if you are pushing something, if you are applying a force on something, you are producing an acceleration. On whom? On the mass of the object, right? Now, the greater the mass of an object is, the greater the amount of force is required to accelerate the object. Yes or no? If you have more mass, you need more force to accelerate. Yes or no? You need more force to apply on it. Now, the second thing is, greater the force on the object, greater the acceleration. Now, make the object constant. It is a simple thing. You throw the ball with small force, what happens? It accelerates, it stops very close to you. If you apply more force to it, if you throw it very hard, what happens? It goes far. So, what does that intuitively mean to you? That means greater the force on the object, greater the acceleration. You are changing the acceleration. The rate of change of your acceleration will be more when you apply more force on it. Alright. So, Newton's second law of motion, the rate of change of momentum is directly proportional to the net external force applied on the body. This is all we have discussed. So, force is directly proportional to the delta P by delta T, right? Delta P is nothing but the change in momentum. Change in momentum by how much time it took to change that momentum. Alright. So, this is the change of time. Now, change in momentum is, this is the final momentum, this is initial momentum. It started with some momentum P1, it reached to some momentum P2. So, P2 minus P1 by how much time it took to change that momentum. Okay, it is changing its velocity from something to something, right? How much time it took to change the velocity from that thing to that thing. That, for example, a object started with 3 meter per second and reached to 5 meter per second in the span of 2 seconds. So, what is the difference in the velocity from 5 to 3? From 3 to 5. So, it gained 2 meter per second, right? In how many seconds it gained? In 2 seconds it gained, right? So, this is the time taken to change this is the time taken by the body to change its velocity. Okay. So, P already you know that if it starts from velocity v1, if the body is starting from the velocity v1 and reaching to some velocity v2, and it took in the time of delta t, because it is the same body, the mass is not changing. So, what happens? You take the mass as common. Okay, mass is not changing there. So, it is v2 minus v1 by delta t. So, what is the v2 minus v1 by delta t? Delta t is change in time. Again and again I am telling, this notation is called as change. Okay, in this much span of time it changed the velocity. So, this whole thing is nothing but the acceleration, right? The rate of change of velocity is nothing but acceleration. So, your force is directly proportional to m into a, mass into acceleration. So, I can, to remove the proportionality constant, I need to multiply with some k. This is the proportionality constant. Easily you can verify that k is equal to 1. take F is equal to 1, force of 1 Newton, mass of 1 kg, acceleration of 1 meter per second square. What do you end up with? You will end up with the k value of 1, k is equal to 1. Okay. So now I can say that force is mass times acceleration, right? Force, your net external force acting on the body of having mass m, what it does, it makes the object move with an acceleration a. Alright, once again listen. If the force, external force of F acting on a body of mass m, what it does, it makes the mass move with an acceleration a. Or else you can tell in this way, if the body is moving, if the body of mass m is moving with an acceleration a, we can say that it is under an action of external force F. Okay. If a body is moving with an acceleration, if a body is accelerating, that means an external force is acting on the body. Okay. If the velocity of the body is changing, means you need to definitely say that it is under the action of an external force. Okay. So mathematically, second law can be expressed as F equal to ma, right, or F is equal to mass into acceleration. Now this is very important, because we can, as I said you, we can deduce so many other laws from this Newton's second law. Okay. If this law you can able to qualitatively conceptualize in your mind, you can play with this laws of motion. Alright. So that's why I am telling you, every now and then I am telling, this is very important and very interesting as well, right? So we have defined what is the physical quantity that defines the motion, momentum, and then from momentum we came to this force. The rate of change of momentum is what? Is directly proportional to the net external force applied on the body. Okay. Now, so we need to know what is the difference between the first law and second law. Second law measures the quantity of force, whereas first law of motion describes the concept of force. First law will tell you if there is force, then only you can change the state of motion. That is the qualitative, that means you are understanding the concept of force there. Yes, force is needed to change the state of motion of a body. But second law will tell you the exact quantity, how much force is required to move a body with an acceleration, with some acceleration a. If you want to move a body with some acceleration, how much force you need to apply on that body. This is the quantity, how much quantity you need to apply, how much quantity of force you need to apply. That is what the second law says. First law says that, so what the force is actually? Force is able to make the body accelerate. Force is that quantity where it helps the body to change its velocity, change its state of motion. Okay. So having studied about force, now let us study about the units of force. In CGS system, force is what? We have studied mass into acceleration. So F is equal to ma. So in CGS system it will be gram. In CGS system what will be the acceleration unit? It will be centimeter per second square. Right. This is for CGS system. So this whole quantity we call as dyne. Okay. Now in MK system, kilogram meter per second square and kilogram meter per second square can also be called as Newton. 1 kilogram meter per second square is equal to 1 Newton. Okay. So 1 Newton is equal to 10 to the power of 5 dyne. We have conversions, right? 1 meter equal to 100 centimeters, like that. 1 Newton is equal to 10 to the power of 5 dyne. So how can you tell that, sir? Please prove. So for this you have this proof. 1 Newton is equal to 1 kilogram into 1 meter per second square, right? 1 Newton, this is 1 mass, this is acceleration. So if we want to change the kilogram into gram, it is 1000 gram. 1 meter into centimeter, 1000 centimeter. So here 3 zeros, here 2 zeros, whole together it is 5. So 10 to the power of 5 gram centimeter per second square. What is gram centimeter per second square? It is nothing but dyne. So 1 Newton is equal to 10 to the power of 5 dyne. Okay? This is it. Now define 1 Newton. If you are asked to define 1 Newton, how do you define it? We know that F equal to ma. If mass is 1 kg and it is and the body is moving with 1 meter per second square acceleration, then F is equal to mass into acceleration. Then it is what? 1 kg meter per second square. Right? How you will tell qualitatively? This is quantitative analysis by using numbers. Right? How we will define qualitatively? Let us see. In the same way, if this force is producing an acceleration of 1 meter per second square and the object of mass of 1 kg, then the force is called as 1 Newton. Okay, to imagine the quantity of 1 Newton, we are defining that if the body of mass 1 kg is moving with 1 meter per second square acceleration, the force which is being applied on the body is 1 Newton. That is the quantity to imagine how the 1 Newton is perceived. Okay, this is about the units of force. Okay, so let us take a small example before we conclude this session. What is this example? Ramu's car which weighs 1000 kg. So here he gave the mass of the car. Now it is out of the gas. This is the mass of gas. Ramu is trying to push the car to the gas station. So he wants to go to gas station now the car is out of fuel. So he makes the car to move with an acceleration of 0.05 meter per second. So this is your acceleration, this is your mass. So if I have to move the body with this much of acceleration, how much force I need to push? Or in other words, he is able to move with 0.05 meter per second square acceleration. So he is asking us to find, the author asking us to find that how much force he have pushed it, with how much force he have pushed it. So we already know external force on the car is being applied is equal to mass of the car into acceleration of the car. What is mass of the car? 1000 kg. Acceleration 0.05 kg meter per second square. So it will be what? It will be 50 kg meter per second square. That is also equal to 50 Newton. So he might have pushed, he might have not, he have pushed the car with 50 Newtons to make it accelerate with 0.05 meter per second square of the car which is having the mass of 1000 kgs. Okay, this is how we need to solve. Let us see. So using Newton's second law, you can also compute how much force Ramu is applying on the car, right? How is that? So this is the car, he is trying to push, mass is 1000 kg, accelerator which is, it is moving 0.05 meter per second, and we already know F equal to ma, therefore by using that we have already solved this. Force is 15 Newtons. Okay, 1000 into 0.05, that gives you 15 Newtons. Alright, this is all about Newton's second law of motion. So this is very important, and in this session we have discussed about the physical quantity of momentum. From there we have got to see the force. And what does the force say? Force, Newton's second law, what does the Newton's second law says? Newton's second law gives the relationship between this force, mass and acceleration. And what is that relationship? F equals ma. Alright, so practice some problems on this, and I will be going to give you some home assignment problems. Please go through this problem. The first problem says that a body of mass 2 kg having a velocity of 2 meter per second is brought to rest within a distance of 2 meters. Okay, so find the magnitude of force acting on the body. So a mass of the body is given, velocity of the body is given, the initial velocity, and it is coming to the rest. Rest means already know what is the final velocity. How much time it took to come from 0 to the rest is, time is not given. It has travelled 2 meters. It has travelled 2 meters before it stops. So find the magnitude of force that is acting on the body. Okay. So think well and you will get the answer. Second one. Which statement is correct? Net force causes motion and net force causes change in motion. Explain your answer and give an example. Alright. A rock is thrown straight up. Rock is thrown straight up. What is the net force acting on the rock when it is at the top of its trajectory? So these are the 3 questions. I hope it is easy and you will definitely solve it. In our next session, we will be discussing about another beautiful topic, that is Newton's third law of motion, the most popular law. And to remind you, there are more misconceptions as well on that law. So let us discuss that in the second law and have a good time. Till then, thank you. Sai Ram.